Hello there. Welcome to Data Communication and Networks, Week 5. Today we will be looking into the physical layer. So, what is the point of the physical layer? The physical layer's entire purpose is data transmission through physical medium. Alright? So, that is the most important point of the physical layer. So, what does that mean? How do you transmit data through physical mediums? Well, essentially what you do is you transport signals. You transport signals that represent data through transmission media. Okay? Okay. So, first things first. Most of the physical layers has many kinds of standards. Why do we need a standard? Hmm? Well, standards are used so that it is mainly based off of compatibility, right? Now, let's say there is no standards. Well, then every company will have a specific setup, a unique setup. So everyone will have to buy either from the same company, and it will become a huge issue for most people. Whereas if you buy from different company, maybe it won't work. Maybe they won't work together. So what standards do is they make sure that regardless of company or manufacturer, every device will work with each other, right? So a good example for this is, let's say there is this length, right? Now I can say that this is a specific amount. Let's say I'm calling it 1 yards, right? What is 1 yards? Well, if I tell someone, hey, I want specific dimensions, I want a ruler that is 1 yards, they will be like, what is that? So instead of saying 1 yard, all I will say is 1 centimeter or 1 meter or 1 inch. These are standard values, right? So that is why we need a standard. Okay. Now, when it comes to the physical layer, data is usually transferred through signals. Now, signals has two different types of formats. One, there is type of signal, and then there is a form of signal. There are two types, digital and analog, whereas the formats are electric and electromagnetic, right? So this is what a signal is. Now, how do we transmit signals, right? How do we send them to the physical transmission media through cables or through wireless media? How do we do it? Well, the answer for that lies in something we call either encoding or by modulating. Now, encoding is for digital signals, right? So you convert data into digital signals, whereas modulating is you convert data into analog signals. Both of them should be suitable for transmission, right? And similarly, when we have signals, to get them back into a data form, we do the reverse of encoding, which is called decoding, and reverse of modulating is known as demodulating. So let us look what encoding and modulating is. Encoding is converting data into digital signals, right? Now, digital signals are ones that go like this, as you may have seen this. So it is discrete, meaning there's only limited amount of values, and in this case there's only zeros and ones, right? So what we can do is there are different types of digital signals. There is unipolar, which has 0 and a positive voltage. Remember, voltage is electronic signals, whereas optic cables have electromagnetic, which is light. Okay, so this is unipolar. And then we have bipolar, which uses negative 5 volts and positive 5 volts. Then there is also binary, where you have two values, you have zeros and ones, and you have ternary, which is negative 1, 0, and 1. Ternary means 3, right? So this is how everything works. So the system that we will learn later on is known as the Manchester encoding. Okay, so the Manchester encoding is what we will learn today. So let us look into Manchester encoding. So let us look a bit into encoding and how it's typed. So you may have learned to see graphs like this, where this is time and this is voltage, right? Where this is 5 volt and this is 0. So you may have seen stuff like this, right? So here we can say 0, 1, 0, 1, 1, and we can say this is 0. How do we draw this in terms of the Manchester encoding? Well, you should realize one very important thing. Manchester encoding is bipolar, meaning it has two values. Okay, it has a negative and a positive, not zero, not a zero. It has a negative value and a positive value. So this is plus 5 and there's a negative 5. So this is voltage and this is time. Secondly, there's another issue that it has. So usually you can separate it into per bit values, right? So I'm gonna try my best to draw as beautifully as possible. So these all should be equal. My drawing isn't that accurate. So the second rule is that every Manchester encoding bit in between has this middle line. Usually people draw it dotted, but since I do not have the capability right now, I draw it in blue color. So right now, let's say we want to do this in Manchester encoding 0, 1, 0, 1, 1, 0, right? So 0 means the line should go from top to bottom, positive to negative, whereas 1 means it should go from negative to positive. So since it should go 0, we start from the negative, we start from the positive and we come down, right? Exercise. And then we come here. Then we have a 1. So since it is simply 1, we can go from bottom to top. Then we have a 0. So it comes down again. So we have something like this. and we have 1 again, so it can go top. But now we have another 1 here. We should go from bottom to top. So what we do is we cut halfway, come like this, and then we go here. And then we have a 0, so we will get something like this. This is how Manchester encoding is done. Remember, Manchester encoding is bipolar and it has a positive and a negative value. These are, remember, the main 2 rules. Okay, it is bipolar and it has to have these sections in between each bit. Now let us talk a bit about analog. So modulation. So modulation is essentially you have an initial signal, right? It could be binary or analog, it doesn't matter. But what you do is you send a carrier signal that changes this, right? Shifts something that changes this along with it. And that carrier signal is always analog. So we know that this is the digital signal, right? There are different variants of it. An analog signal is something like this, where we have amplitude. This is an amplitude. This is going to be the peak amplitude. This is going to be a cycle or wavelength, right? Frequency is how many cycles in 1 second, right? How many cycles in 1 second? Period is how long it takes, so time for 1 cycle to complete, and phase is the angle on which it begins, right? Angle it begins. So we have 3 different parts. We have an amplitude, which we care about, a frequency we care about, and a phase we care about, right? So what you do is you take a binary or analog signal, right? And then you add a carrier signal to it. But what you do is you shift a little bit. So for instance, you shift either frequency, you shift either amplitude, or shift either phase. Oh my God, this word. Do not think much of it, my dear students. But we can only shift one of them at the time, right? At a time, right? So if we shift frequency, so let's say we have a wave like this. If we shift frequency, let's say we make it higher, we can get something like this. If we make it slower, we can probably make it something like this, right? If we shift its amplitude, we can make it go higher or we can make it go lower. And if we shift phase, so phase has 2 parts. We can shift 90 degrees or we can shift it 180 degrees. If I shift this 90 degrees, right? If I shift this 90 degrees, then all I'm doing is I am technically starting it like this, right? So it's half is cut. If I do 180 degree, it's gonna start from the bottom. Okay, so this is what modulation is. So when you shift amplitude, you get amplitude modulation. When you shift frequency, you get frequency modulation, and when you shift phase, you get phase modulation. Doesn't AM and FM ring a bell? These are radio signals that we use. So when you shift AM, when you shift amplitude, you get amplitude shifting key. When you shift frequency, you get a BP, BFSK. I think it's binary frequency shifting key. And if you shift P, you can get binary phase shift key, right? So this is all the types of shifts that we have learned, right? So this is what we have learned in physical link. So it's the physical aspect of most things. I believe in coming week we will learn about the different types of transmissions, what types of cables we use, etc. The issues that arise with transmissions, for instance, attenuation, propagation delay, and all that stuff, and so on and so forth, right? So until then, this is all what we have learned, and I hope you have a great day. Before I leave, I would like to say one small message. Remember, you are loved. Remember, you are cared. Remember, you are important. Always know that there is light at the end of the tunnel. The dark is dangerous. The dark is scary, I know, but hold on to yourself. Be happy. If you're feeling unwell, if you're feeling sad, make sure to talk to someone. If you can't talk to your parents, make sure to talk to a therapist. If you can't afford a therapist, just try to call a national helpline or anyone and try to talk your issues out. I remember you are loved. Remember you are cared for. Anyways, have a great day.